Okay, so today what we're going to do is we're going to build our own little weather station. Our weather station is going to display the temperature, the pressure, and the humidity. And I'm even going to show you how to log that data in case you want to do analytics later. That sounds good. Let's get started. Okay, so to get started, we already have the barometer.py file created, and I already have the basics on my code already started. So I do have from Sensat import Sensat to enable me to use that package to interact with my Sensat on the Pi. And then I got the time just in case I want to do some time delays. For the instance, it's just the standard Sensat, and we're naming it Sense, and this is pretty standard, so we're going to keep that the same. And then when I use my LED, I always want to keep that low light. It's just easier on the eye, so it's not as bright. So what we're going to do is look at those temperatures, the pressure, the temperature, the humidity, and all that stuff. So how do we do that? We'll start by looking at the pressure, and what is pressure? It's an atmospheric pressure, sometimes called a barometric pressure, and that's actually measures in hectopascals, which is HPA. And typically, at sea level, it's around 1,000 HPA at sea level. What do we use it for? Well, we can use it to predict weather, for example. So if the pressure is falling, it's probably a storm coming. Also, if pressure drops, its altitude increases, so we can estimate the altitude. So there's different things we can do with it. So to get the pressure, what we're going to end up doing is we're just going to create a variable called pressure, and we're going to do the sense dot get pressure. And getting the pressure is simple as that. And we know that the measurement is HPA. And then that's it. We just put the pressure in the variable called pressure. So let's print that out. So if I do print pressure, that's going to end up printing the pressure out for me. So if I go ahead and hit save, and I can actually run this, and then I have the pressure right here, and notice it's really long up here. And if I didn't know what this was, it's just a number, right? So let's make that a little bit more clear. So let's go up here and do the F string, and we'll say this is the pressure colon, and then we'll read the pressure. So we'll need our brackets for pressure. Okay, and then what we're going to do is we're going to format that into a 2 decimal float. Okay, and then we know that the unit of measurement is HPA, and then we'll close the quotes, and then we'll save this. Now when we run this, now we have the pressure that's in HPA. We know it's the pressure, and then we know it's the measurement. And getting the pressure is simple as that. Alright, so the next thing we're going to really look at is the temperature. And, we're going to measure the ambient temperature. So basically, how hot or how cold it is. And we're going to use Celsius as the degree. And one thing we got to realize is that on our Pi itself, it can get a little bit warm due to the CPU that's processing on it, and it can produce some additional heat. So some of your temperatures may read a little bit higher off the Pi than off your thermostat, so just take that into consideration. Alright, so to code the temperature, it's pretty much the same thing as up here. We just got to call it, and then we got to print it out. So it's pretty straightforward. So what we're going to end up doing, we're going to do temperature, TEMPERATURE, equals, and then that's going to be sense dot get, and then it's going to be the temperature again. Okay, and then we're going to put the unit of measurement up there for we'll know what it is. Now the same thing down here, we're going to print, we're going to do our F string, we're going to do the temperature, and we're going to call the temperature. Okay, and then we're going to do the format again. So we're going to make it a float with 2 decimals, and we're going to put the unit of measurement. So again, I'm talking about this here, just a string. This temperature right here that's white goes to this temperature up here, which is getting this variable, or this is the variable over here, I'm sorry, and then it's calling the instance over here. And that's pretty how much that's working. It's pretty straightforward. We'll go ahead and save this, and then when I run this, I get my temperature right here at 33.14 degrees Celsius, and I can run it again, and I got the 33.19 degrees Celsius. So that's pretty straightforward. Alright, so if I want my temperature like in Fahrenheit, I could do that as well. What I could do is I'll just leverage what I already have up here for the Celsius, and I'll just do a conversion. So I can do temp, and I'm just going to call this underscore Fahrenheit equals, and then that's going to be temperature. Okay, and that way I'm calling this really from the temperature variable. Okay, and then I'm just going to do the conversion. So I'm going to multiply that by 9 and divide that by 5. Okay, and that I want to make sure my orders of operation stay the same. So I'm going to put that in parentheses right there. Okay, then I'm going to add 32. Okay, so that's how I am going to do this. So I'm going to take the temperature times that by 9 divided by 5, and then I'm going to add 32 to it, and that should give me my Fahrenheit. And then down here, same thing, I'll just print it out with the F string, and then I'll put temperature, there we go, and then I will say this one's going to be the temp underscore F for Fahrenheit, and that is again going to be 2 decimals. And we'll finish this off with the Fahrenheit. And then up here, I'm just going to make sure that I comment and put, and these are comments, so it doesn't really matter if I put them up here on the inline comments. I just like to do that just as kind of a reminder what it is. And then down here, when we print it out, we'll know the unit of measurement is all we're doing there. So let's go ahead and save this. And then we'll open this up, Python Barometer, and then we'll run that. And then now I got the temperature, which is like 91.74 degrees Fahrenheit, which is pretty warm. So, we know that it's not like 91 degrees in here. At least I hope not, because that means my air conditioning is not working. So, we mentioned earlier that the CPU plays in a factor of throwing this temperature off. I didn't quite realize it'd be that high, so let's fix that. Okay, so how do we do that? Well, let's go up here and we'll import OS. We will import OS. Okay, So now that we imported OS, we're going to have to do, let's do this. Let's do calculations. That way we'll keep our calculations separate from our display. Okay. So now that we have this, let's think how we're going to code this. Okay. So we're going to need to get the CPU temperature. Okay. How are we going to do that? Well, we're going to do the OS dot, and then we'll do P open, and then we are going to do the VCGENCMD, and we want to measure the temp. And then we are going to do dot read and kind of read that out. Okay, so that's going to be pretty much it right there to kind of read that. So let's go down here and print this out. Okay, so if I print the CPU temp right here and save it, and we'll go ahead and run this really quick just to kind of show you what it looks like. And it says string objects has no attribute to read. Interesting. Oh, yeah, that's why. Okay. I put my close brackets or close parentheses in the wrong place. Okay, so let's go ahead and rerun that. And see, now I have the CPU temperature already laid out. Now, I want to use this number for our calculations. So I can't do that because I got the temp and I got this C like right there. So to do that, to kind of get rid of those, let's do this. Now we're going to do a dot. We need to replace it. And what are we replacing? Well, replacing the temp equal sign. Okay. Then I'm going to bring back nothing. Okay. And that's going to take care of this temp equals right here down in our output. So temp equals will be removed and replaced blank. And then I got this -C right here. So I'm going to copy that and I'm going to bring this up here, and I'm going to do the same thing, same format, dot replace, and then we're going to end up putting in my quotes here, and that's it right there. And then I go back over here and I'll hit the I'll have to look around my mic, but I'll hit the comma and then close out those little like quotes right there, just to bring back an empty space, and then we'll save this. Now let's rerun this code, and it says replace is not defined. Okay, so right up here, I fat fingered my key. I put a slash when I was supposed to put a dot there. It's right next to the keyboard, so I made a typo right there. So let me go ahead and resave this and then kind of run this, and then there we go. Now we have the 48.3. Okay, so you know, we know from programming that this right here it looks like a number, but it's actually a string, because you know we're using string commands and we're removing text from that, so that 48.3 is still a string. So we need to change that to a float. So that's real easy up here in the code. If we go back to the beginning of it, we just type in the words float and then put the open parentheses, and then we go all the way to the end of the code. Okay, and then we close that out, and then I hit Control S, save it, and then if I run it again, okay, it looks the same, but this is now a float, so we can actually do calculations off of it. Okay, so now that we got the temperature kind of defined right there for that CPU, let's do some math and fix our temperature and kind of get that corrected temperature with this. So how do we do that? Well, we already have the temperature up here with Celsius. We just need to correct that. So let's go with the corrected underscore temp equals, and then we're going to do the temperature, and we're going to minus, and then we're going to minus the CPU temp minus the temperature, because remember these were both in Celsius, so minus temperature, and then I'm going to, don't need that, so minus CPU temperature. So I got temperature minus CPU temperature, yeah, and then I'm going to minus that. Actually, it's going to be divided by 1.5. There we go. Okay, so I put this in just for my orders of operations, just to kind of, because I want this done first, and then I want it divided, and then I wanted to do the temperature minus. So just get my orders of operations, together how I wanted it. So now I got this corrected temperature. Okay, so now what we're going to end up doing is I'm going to kind of copy this temp F right here. I'm going to comment this out just to keep the original up there, and then I'm going to paste it down here, and then I'm going to measure the corrected temp for my measurement right up here. So I got the temp F equals corrected temp times 9 divided by 5 plus 32. So this is going to get my correct Celsius reading on there. So now my temperature up here in Fahrenheit is going to read closer to what it should be. Okay, so now I don't need this print CPU anymore, so I'm going to go ahead and take that out. Now if I save this and I go ahead and run this, my temperature right here should be in the 70s something if it's correct. So if I run that, and it says it's 73 degrees, which is probably correct. So my thermostat says it's like 72 degrees right there. This says 73.87. So it's pretty close. I'm talking about, it's not perfect. So we had to do a calculation to account for the pie's heat on that, and we got it pretty close. And I think that's pretty good enough for what we're doing. Okay, so we know that this temperature, like up here in Celsius, is still like not calculated the way it should be, and we could just go down and we can put the corrected temp down here instead of temperature to kind of get that in there. But instead, what I'm going to end up doing is I'm just going to put temp underscore C for Celsius equals, and that's going to be corrected temp. Actually, I'm not going to do that. I'm just going to do it this way, I think up here, instead of for the corrected temp, this is just going to be temp underscore Celsius, and I'm going to change this corrected temp to temp underscore Celsius, and that way I'll keep my right temperatures in here. So if I go ahead and save this and go ahead and run it again, we're going to see a difference in, because I still have the temperature up here, I didn't change my variable. So this should be temp underscore Celsius. And then now we should be able to see the results down here when we run it. So now we see the temperature drop 23, and we see, right here, we're still in the 70 range, which we know that it's a couple of degrees off. Again, since it's on the Pi and it's a little bit warm, it's not perfect, but we do have to do some calculations for the CPU to kind of keep it in range. So I think that, like a degree or two is acceptable for my purposes. If you have a better calculation, please let me know in the comments below. Alright, so the other thing I want to show you is the humidity. And we'll just kind of measure what the relatively humidity is. That's a percentage based measurement. We're going to say, 0% completely dry, all the way up to 100%, which is like saturated air. And, we use the humidity to kind of understand what the comfort levels are. If it's too humid, you might have that sticky feeling. Dryness, you're going to sit there and feel that when you breathe with your nose. It's going to be kind of like really dry air. And we could use this for like you possibly track conditions for mold provision, or check the indoor air quality, etc. So let's go ahead and figure out how to do the humidity. Okay, so to get humidity, we're going to go back up here on our code, and inside our calculation section, what we're going to do is do humidity. HUMIDITY equals, and same thing, you guessed it, sense.get, and that's going to be humidity. Okay, HUMIDITY, humidity. Okay. And down here, we're going to have to print that out. So we're going to print, and again, we're just going to format it up front. HUMIDITY. And then we're going to call the humidity. And again, just make it a float with 2 decimals, and then this is going to be in the percentage, and make sure I put that right there. And up here I'm going to put the percentage up there as well, and that's pretty much it. And again, this is the comment. Okay, so down here, humidity to float percentage. Okay, that looks good. So we're going to go ahead and save that, and then we're going to sit there and run this. And we run it. The humidity is 34.43%, which this is in the acceptable range. Like ideally, like indoor, you want between 30 to 50% humidity to feel comfortable. Under 30%, your air is usually like uncomfortably dry, so you have dry skin, dry throat. 50 to 70% of humidity, that's again, where you feel kind of sticky and uncomfortable. And if it's greater than 70%, that's going to be very humid, and that's when you have the risk of mold forming and condensation on there. So, right now, I'm pretty comfortable at 73 degrees and with a 34 humidity, so I'm doing pretty good. Okay, so now that we got the basics down, and we got that information, we want to be able to kind of display that on the sense hat. So when my pie is like up here, I want to see it display. So how do I display that? Well, it's pretty simple. As you know from like previous videos, to display, we do sense dot show message. Let me AG. Okay, so we do the sense slow message, and we're going to do a string, and we're going to format that. And then what we're going to end up doing is, let's get the temperature, and we'll just do a T here, and the temperature, we're going to want the Fahrenheit. So let's just copy this right here so we don't have to type it in. Okay, so we have the temperature for Fahrenheit right up there. The next thing we want to show is the humidity. So we're going to do the humidity, and we're just going to copy this part right here, and we'll put it in the humidity. That way, yeah, I don't want a space. I'll just keep it straight up against that. And I'm going to probably bring this back and then bring this percentage back. I just think it would look nicer. You can keep the spaces in there if you want. It's not going to hurt anything. It's just when you display it, it will have a space there. I don't necessarily want a space between that. Now, what I end up wanting to do next is, I'm not going to put a comma there. Actually, I'm going to put a pipe there, and to kind of separate it. And you can put anything you want to separate it. I'm just going to put a pipe. So from there we got the humidity, and then the next thing we want to do is kind of, I guess, the pressure. So let's put the pressure in. And the pressure, we're just going to copy it from up here. There we go. And we have the pressure, and then again we'll just bring back the HPA all the way up there, and that should be it for that. Now what we can do is we're going to do a comma after our string is finalized, and we're going to set the scroll speed. And we're going to set that scroll speed to 0.05. Okay, just to watch it scroll across. And then we'll go ahead and hit Control S, and we'll save that. And we'll go ahead and run this and, give it a try. Okay, so let's go ahead and run this, and I'll hold my pie up here so you can kind of see a little bit better. And then you'll see the temperature and everything run across the way that it should. So we got everything working. So what's next? Well, we don't want it to run one time. We kind of want it to repeat, but we don't want it to kind of repeat itself like all the time where it just keeps going across. We want it, let's say, every 10 seconds. So how do we do that? So it's pretty simple. We're just going to do time dot sleep, and then we're going to do 10 seconds. Okay, and as you know that you're going through the code and like, oh well, we're going to wait 10 seconds, then what? Nothing's going to happen. You're right for now. So we're going to highlight all our code going up to our calculations, and we're just going to hit tab to kind of tab it over. Up here we're just going to type in raw true, just like that, and then I'll put a capital T, There you go. While true, this is going to happen. So it's going to go through all these calculations, and then it's going to run this. It's going to wait 10 seconds, and then it's going to run everything again. Okay? So that's going to be pretty straightforward. So we'll go ahead and save this, and then we run this. We'll see that our pi is going through, and again, simple as that. It's going to wait, and we're going to wait like 10 seconds. So after 10 seconds, you're going to start seeing that display populate again here. So there it goes again. So every 10 seconds, you're going to see that change. And you can just hang this up on your wall or something, and then you can have your own display keep displaying through. And setting up like a little weather station for home use is easy as that. Okay, so what else can we do? Well, for people who want to do analytics with this and kind of like, make charts or like look at stuff over time, or just kind of collect that data for simple data collection. So how would we collect this data? Well, let's break out of our loop here by hitting Control C, and then we'll go up here at the top, and there's a couple things we want to do. We want to import a CSV. Now we could put the data in the database, but for now we're just going to put it in a CSV, because I'm not planning on keeping this data. But you might. So, if you want to keep a big CSV file going, or you want to keep a database, that's fine too. But for now, we're just going to do a text file. Then I'm going to do from date time. I'm going to import date time. Okay? So from date time, import date time, just to kind of get that timestamp. And then going down here at the very bottom of our code, and I'm going to bring that up here. There we go. So that's going to do the display, and then I'm going to put down maybe data capture right here. And then I'm going to do with open, and I'm going to open up my CSV file, and what do I want to name this? Well, we'll call it weather log, I guess. .csv. Then we are going to every new line equals, there we go, and this is going to be as a file. Okay, so basically this like that just depends, so we're not writing over the data. So when we open the file, we're just appending the file over and over again, is basically what that's doing. Okay, so now we're going to take a writer, and we're going to have to do the CSV dot writer, and we are going to write to the file. Okay, so we're going to open this as a file, and we're going to write the file, and the writer variable is going to be writing to that file. So now we want to do writer dot write row, and we'll end up doing the date time dot now to kind of get the timestamp. Then we're going to get the temperature, the humidity, and the pressure. So if I go up here, I'm going to want the, let's see, we'll do the temperature in Fahrenheit. And let me think about this for a minute. Yeah, we'll do it this way. We'll do the temperature in Fahrenheit because I might want the full numbers in case I'm doing some calculation stuff, I want to be a little bit closer. So we're going to have the full decimals going all the way out. So we'll do the temperature, we'll do the humidity, and then we are going to end up doing the pressure as well. Okay? So if everything works right, what's going to happen is we're going to create a weather log CSV file. It's going to start recording the date, time, the temperature, the humidity, and pressure. This is going to go every 10 seconds right here. So, and actually, we're going to put the 10 seconds at the end, just like this. That way, we'll have it read everything and then wait 10 seconds and kind of go on from there. So let's go ahead and save this, and then we'll go ahead and run this code, right? And then it starts running, and it should run, and if everything goes right, we'll create that file. And it says it has no... Okay, so we did have a typo. So up here, that's my typo, W-R-I-T-E row. That'd be another typo. Okay, so right row. So we have that on there. So let's go ahead and save this, and we'll go ahead and try running this one more time. So we run that, and we got a temperature, so we got everything in there. It's displaying all the way across, and when it's done displaying, it will go to our next part, like right here, to actually write to the file. And then we'll give it a second, and we should see it pop up over here for the file name. And I might have to do a refresh on this, so let me refresh the data. There we go. So there's my weatherlog.csv file. So if I open this up, we see that it's writing the information up there. So everything's working the way that it should. So if I want to use this data later on, we can use this data later on. So if I want to do some type of data analytics, or I just kind of want to measure this in a chart over time, we can actually see that. And setting it up is as simple as that. So if I go down here and hit refresh again and open up my log, you see I'll have more log information in here. So everything's going to add every 10 seconds, and we can use that again for analytics later. So some of the other projects that you can do with this knowledge, since we have the local weather logger, you can check the trends, and then maybe run it for a few years and kind of see the changes in weather. You can analyze the rising in pressure and falling in pressure, and if it's steady, you can make the LED lights light up depending on what you want to see. You can look for pressure drops and do the storm warning alert system. You can use the log data again, maybe build a machine learning project to kind of predict the weather. So there's plenty of different things that you can do with this. Just let me know what you are going to do with yours in the comments below.